Hi there, Serdar Yegalov here for InfoWorld at IDG. Today I'm going to demonstrate Cython, a system for compiling Python code to C for the sake of boosting performance. As many Python users know, Python is convenient but not always fast. C, on the other hand, is fast but rarely convenient. Cython lets you get the best of both worlds. Cython provides a custom set of type annotations and syntax elements that extend Python and allow it to be compiled to high-performance C. Existing Python code can compile as is with Cython, but probably won't gain much of a performance boost in that form. However, if you add Cython's type decorations, the resulting C code can be optimized enormously, sometimes by many orders of magnitude. Cython is most effective when optimizing Python code that's numerically intensive, like algorithms. You can write a slow prototype of an algorithm in regular Python, then convert it to Cython for production speed. What's best about Cython is that you can perform this conversion incrementally. You can start with the code you already have and optimize its performance gradually instead of rewriting the whole thing from complete scratch. To demonstrate how Cython can speed up Python code dramatically, I'm going to use a visual example, a Python implementation of Conway's Game of Life. For those who don't know it, Conway's Game of Life is a mathematical game, a simulation of a colony of cells as they grow, reproduce, and die off. Because Conway's Life is mathematically intensive, it makes for a good stress test of a language's raw performance. Here, I've written two versions of a Conway's Life program. The first is in pure Python, and as you can see, it runs very slowly. The numbers you see popping up there are a rolling average of the amount of time it takes to compute a new generation of cells, around 0.3 of a second for a 400 by 300 array. And that's after we did a lot of tricks to speed it up as much as we could, like using a pre-computed lookup table. Since that computation is almost pure math, it's a great candidate for being Cythonized. Now let's look at the second version of the program. Some of the key functions have been moved out into a Cython file, which uses a .pyx extension. When we use those Cython versions of the function in our main program, we just import them straight in as if they were regular Python objects. That's another reason Cython is handy. It works with your existing Python apps naturally. As you can see, the Cython version of one of the key functions is almost identical to its Python original, except for the presence of type declaration syntax. Many existing Python constructions, like the range object, translate naturally into C, provided we're using C types for the variables in question. Incidentally, this function also makes use of another powerful Cython feature. Many Python objects, like strings or arrays, use what's known as the buffer protocol, a way for a C extension to access the raw binary data used by the object. This way you don't have to go through the Python runtime, which is slow, to get to it. You can just access the data as a raw byte array. We're making use of this feature here, accessing the raw data of the self.life arrays so we can read from and write to them directly. And bear in mind, this can be dangerous. You may need to make sure that no other Python objects attempt to access the same data in the meantime. And you can always use safe object access for things like arrays at the cost of some performance. But this kind of power is available throughout Cython whenever you want to reach for it. Before we can use the Cython version of our life program, we have to compile the Cython components to a library module. I've written a helper script here to do that. If you're on Linux, Cython will use the C compiler available on your Linux system, typically GCC or Clang. Windows users should install the Visual Studio C compiler, available for free, which is what I'm using here. Now, when we run the Cythonized version of Conway's Life, you can see a dramatic speed up. And the amount of time spent on calculating each new generation of cells is at least 2 orders of magnitude smaller. Cython also provides you with visual tools to get an idea of how optimized your code is. When you compile a Cython module, it generates an HTML report file alongside it. Lines in yellow indicate that the code isn't fully optimized because it still references Python objects in some way. If you click on a yellow line, you can see the underlying C code. The functions where we do most of our hard work, generation and render, are almost completely optimized. The only unoptimized code is in the setup parts of the functions, which we can't do much about, and they don't run in tight loops anyway, so they're not a major source of any bottleneck. But up here in the init function, which sets up some of the fast lookup tables we use to compute each generation of the game field, we see a lot of loops and a lot of yellow. That's because this function is more or less a straight port of the Python version with no type information added to it. If you don't add any type information, Cython assumes the variables in a function are just generic Python objects, resulting in slow code. To speed this up, All we have to do is add explicit type information by way of these two lines here. And as you can see, after recompiling, the function is now pure C. There's a great deal more to Cython than what I've demonstrated here, like interfacing with existing C or C++ code or using multithreading. But this demo should give you an idea of how Cython gives you the power of C and the convenience of Python together. If you have questions about this video, please add a comment below. Don't forget to subscribe to the IDG Tech Talk channel on YouTube, and for more Python tips, be sure to follow us on Facebook, YouTube, and Infoworld.com.